So when I was trying to help curate what would be our DevOps Days Minneapolis 2016 program, one of the things that mattered a lot to me was making sure that we got both the voices from inside our local community and from the world at large, the wider, DevOps sphere, or whatever you want to call it, of people who are out there having these conversations, people who are out there speaking in public and also doing a lot of this stuff. I feel like Charity Majors needs no introduction, and yet here I am. And the reason that I wanted Charity to come speak to us so badly and was so excited that she made time in her, spoiler alert, startup founder, in stealth sort of moment. She made time in that to come talk to us because the stuff that we're all trying to make decisions about every day, and I think I had people raise their hands earlier, and 98% of the room raised their hands and said they're at large enterprises, but when they're trying to make these decisions, whether at a large or small enterprise, and she's worked at one of the largest, there's still so many decisions that are hard to make. And so thank you so much for coming and talking to us about technical decision-making, Charity. Give it up for Charity Majors.
Thank you. Oh, I have a microphone. Thank you. Hi, my name is Charity. I have a few hypothetical, third-party, super irrelevant questions to ask you. How many of you have ever overcommitted yourselves a little bit? Perhaps not prepared as fully as you intended? How many of you have ever gone to a conference that you were really, really excited about and spent the entire time on your laptop debugging shit? I'm really looking forward to the, my favorite thing about DevOps Days is the open, unconferencey things in the afternoon. I missed all of yesterday's. I was super bummed, but everything's fixed now. So yeah, those of you who are raising your hands, y'all are my peeps. The title of my talk, it comes from a book by Neil Stephenson called A Young Lady's, The Diamond Age. Have you guys read this? Right? This has been so good. It's one of my favorite books. It's a cyberpunk story, right, about the future, the glorious future, where the world and our bodies are teaming with nanotechnology, little robots. All their buggy little software. You should read it. It's really just the inevitable next step of what every single VC will tell you, which is that software is eating the world. And I will tell you that it's soon going to be eating our brains. So kind of in preparation for that day, I would like to talk about software and technical judgment. We'll talk about the problem, where the world's headed, and some quick tips for survival. This is supposed to be the actual title of my talk, Good Choices and Other Impossible Things, and then I just gave up. Technical judgment is something that we all do every day, right? I don't care if you're startup-y or enterprise, whether it's a new project. Microsoft is calling it brownfield development, where they're doing kind of greenfield inside old stacks, right? We make a lot of choices every day, often without really being conscious that that's what we're doing. And unfortunately, it's getting harder. Now, we're all Sciency engineer types here, right? So to prove this, I did some science for you. And I made an extremely sciencey graph for you. So as you can see by my precise calculations, nobody on Earth is going to be able to make any decisions within about 6 months. It's just going to be too hard. And you can tell it's true because I have a graph. So, how did we get here, right? 15 years ago, we had the lamp stack. Who here is old enough to remember when the lamp stack was hot shit? Yeah. Oh my God, the battles between like MySQL versus Postgres, or Perl versus like this upstart Python, CGI bin. Oof. That brings back memories. And then like 10 years ago, right? Or like, well, this this sucks. This is not maintainable. And we started unpacking these applications from these giant monoliths and CGI bins into loosely coupled services, right, with your REST APIs. And at the time, like, it seems super obvious and trivial now, but at the time, for those of us, like, I was just starting my career, it was scary. It was really confusing and complicated to, like, figure out this from scratch. And scarier yet, like, we had to take a lot of infrastructure and code that was working and break it in the hopes that this would eventually make things better. Yeah, we knew that we had to change things. We knew that we had to be more resilient because doom was clearly on the horizon. We get through it. We get used to it. Now this all just seems like table stakes. It's completely boring, right? Config management. Even just like, 5 years ago, you had a pretty, reliable set. You had a cookbook, right? You had, config management, virtualization of some sort, continuous delivery, continuous, testing. All these things went from being scary and new to being just like obvious. And like personally, the last time I was spinning up a new infrastructure from scratch was Parse, 2012, right? And it's like, Puppet or Chef, whatever. So the genesis of this talk was in like January is when I co-founded my new startup, which I'm super excited about. You're welcome to come and ask for a demo after the talk anytime. But like, I came in, I like swooped into this with like a certain amount of confidence. Like, I basically know what I'm doing, right? So let's just decide what to do. And holy shit. That was a little bit paralyzing and sobering. And if you know me, you know I hate to be sober. But like, seriously, a lot of trends that have been kind of percolating on the horizon became viable, right? They tipped over into not being crazy and insane and, only the people who don't care about their uptime are going to do it. Docker, Rocket, etcd, the CoreOS stuff, all the schedulers, all the, I felt like I was pretty good at this stuff, and I'm like, well, shit. If I feel like paralyzed by this chaos, how does everyone else feel? Are we just like not admitting that we're all terrified? Yeah, basically. So out of all this chaos, like, what are the high-level patterns that are important that we should really be paying attention to? I think that there are some really strong themes, right? Nobody can just have a database anymore. And it sucks because this is one of the most heavyweight things to scale and maintain, right? Is something that stores your data. Believe me, I am a data person. You now need polyglot storage. Composable infrastructure is complex. It's been promised for a very long time. It's actually starting to be a reality. Containers are kind of growing up. I'm not yet willing to like bless them. We're definitely gluing together more third-party platforms than ever before, and trust software as a service with key elements of our stack, because we're realizing how expensive engineering cycles are. And we'll talk more about that later. But what all of these trends have in common is they increase complexity and they change the definition of what operations means. I'm really passionate about number 2. My talk is mostly about number 1, but we'll see how much time I can get through. I think this is really an exciting time. Those of us who are not Google and Facebook, those of us who are in the open source world, we're now getting access to the same kind of tools that they have had for years. And you might think, oh, well, more choices, awesome, great. Yes, it will be. This explosion has so much creativity and excitement backing it, but We're heading to a better place, but in the meantime, like, this is actually really legitimately hard on people. It's really cognitively overwhelming on the humans who are trying to navigate the space, like me. There are not very many established best practices, and if you go looking for best practices, you get a whole bunch of conflicting answers, mostly because the people who are trying to give you answers are vendors, and everybody knows that vendors lie. And I say this with no judgment. I'm about to be a vendor, and I'm going to lie to you too. I'm going to be like, oh, your world's going to be so great if you use my shit. It's cool. Like, my role as a vendor is to get you to battle harden my stuff so that it'll, sorry, trade secrets. Does this mean that you shouldn't use any of it? No. The future is here. It is better. And the ways are generally better than the old ways. But it means that we do need to think carefully about, on an individual level, like our tolerance for risk, our appetite for risk as an organization, and where to spend that risk so that you can have the maximum impact. So I have a few just sort of top-level guideline tips for thinking about new technology adoption that were really helpful to me, and I hope will be helpful to you. And I find that like these are the kind of tips that your senior engineers are already using. That's why you called them your senior engineers. And it's not always conscious, right? Often this comes from an intuitive base, like from wounds and scars, or just like being hit in the same place multiple times really hard. And they're just like, ugh, I can't explain to you why that's a terrible idea, but it really is. And you trust them, because it's true. So kind of what I want to do with this talk is unpack that intuition. Like, where does this come from? Where do these battle scars come from, and how can we avoid, how can we learn through them through talking instead of like with a baseball bat? Let's start with the prime directive. This is a blanket statement, and I'm just gonna boldly say it. This applies to every single one of us who works with technology. As Captain Picard would say, your technology exists to serve your mission, not the other way around, ever. What is your mission? I don't know. I mean, maybe it's like getting people healthcare. Maybe it is, making the world more open, connected was Facebook's slogan. Building software is not your mission. Like, even if you literally write a database, it is not your mission. Like, your mission is, that's just a layer of abstraction, right? Your mission is to do a better job of empowering your customers to achieve their missions. In fact, I find it far more helpful to think of software as the enemy. Not kidding. Every piece of software that you add to your stack adds a point of fragility, of unpredictability, of chaos, of failure. Every piece of code that you write yourself, you will be maintaining, debugging for years, or someone else will get saddled with your shitty code, and that is the absolute best case outcome. Code is actually liability. The best code is no code. The second best code is code that someone else wrote. A bunch of people have battle-hardened and maintained for you, and you can still read and debug if you have to. And it's easy to lose sight of this, right? Because we all love tech. We got into this because we love it. But as a technical leader, like, your main job, one of your very top jobs, is to make sure that the technical decisions that get made are in service of your mission. And that generally means write as little software as possible. Seriously. The first principle, oh right, I'm counting from 0. I was in Britain when I wrote this. Resist software sprawl. Reuse your solutions and your components whenever possible. Now there's a link there. I'll put these slides on the internet. Jesse wrote the awesomest blog post about this, basically about how, when you're letting your engineers innovate and fuck around. Play with things. Let them do it on the developer tooling side of things. There's this whole continuum of risk and danger that goes from like, oh, what developers use to like build their tests to like where your data is stored, which is like green to red. It's a great post. But like because for every storage component that you use, right, you have to monitor it, graph it, understand it, have people on call for it, upgrade it, maintain client compatibility, write libraries for it, scale it, migrations, transfer. It's a big commitment, and you should reuse the things that you already know and you're already good at wherever possible. The same goes for languages. A company can only build up expertise in so many languages because it's not just writing the code, right? It's the test frameworks and the deployment and okay, another way of putting it, as Dan McKinley, who I also love, says, is optimize globally rather than locally. And startups, you know, you can give them a pass on this, but enterprise people, how many of y'all identify as working in enterprise? Yeah, so this is a lesson that you guys already know very well. If you let every team or every project, every product choose the perfect language and the perfect data storage for every local problem, you end up with an incomprehensible nightmare. If you're a baby startup, local chaos is fine, right? Because you should be optimizing for experimentation and rapid iteration, because almost no startup ever went out of business because they moved too slow. But when your time horizon is longer, which is a sign of success, you need to shift your focus to maintainability, which means having some process for adding major new components to production, whether that's a new language or a new storage engine or whatever. Like, it shouldn't be impossible, but there should at least be enough friction, appropriate amounts of friction, to make people stop and say, wait, can I do this with the tools that we already have? That's all, right? Also, what is the relative gain? Because if you are an Ubuntu shop and some douchebags are like, I'm going to run Red Hat, like, no, no. You can make your case, give it a try, but no, like, that's just unnecessary. And the number of times that I've been through that. On the other hand, like, if you're using a language that doesn't have concurrency and you're running into problems with scaling, and you're like, well, shit, we might actually really need a language that handles concurrency. Cool, but go into it like eyes wide open. And just don't micromanage outside the critical path, because that's what matters. Like Dan McKinley said, again, I love this dude. If you haven't read his blog post, this is like one of my favorite blog posts of all time. Choose boring technology. This is where the innovations tokens thing came from too. The thing about technology is, she said from her high mountain, new software is going to break in ways that are unknown and unpredictable. So it's not even about breaking in the ways that are known. That's fine, that's tractable. It's about the unknown unknowns. How is this going to break in ways that neither I nor anyone else knows? That's kind of terrifying. And boring really doesn't mean bad. Boring software runs the world. Like, boring is like Python or cron at this point, you know? Like, boring means that the failure modes are well understood. There's rich library support. There's an ecosystem. You can look up errors in Stack Overflow or Google or whatever. You're not alone in the world. So use it, like, when you can. But the corollary of this axiom is the earlier your startup, or for like big companies, the younger and more experimental your project is, the more risks you should take. Because this is your competitive advantage, right? This is how people get to disrupt the status quo. By taking more risks, by being more nimble, by leveraging newer technology, because as much of a pessimist and a cynic as I am, yes, software is getting better over time. It feels weird to even say those words. But you have fewer sunk costs, right, in the old way of doing things. You probably have fewer humans, so you can get away with more localized chaos. You have fewer customers to affect. This is the thing that I am glorying right now. They have very low expectations of you. Low expectations can be an advantage, too. Use it while you can. So some good reasons for like supporting some new components is like bottom line, is this critical to your mission? Like, does this enable you to succeed in a way that nothing else can? And if you're replacing or upgrading a thing, that's great. But one of the big problems that I see technical leaders do again and again is they say, yes, we're going to replace this, but they don't prioritize getting rid of the old thing. And then you're stuck with two things. A very successful company in Silicon Valley, which I will not name, made the decision to switch from Puppet to Chef a few years ago because they hired a Chef contributor. And they're like, Chef is quantitatively better than Puppet. Sure, we'll change. I'm with you. I prefer Chef too. But they are still to this day running both on the same hosts. They've lost engineers over this. And it's like, fuckers, you should have just stuck with Puppet. The cost that they have paid has not been worth it. Yeah, if you're getting rid of something, get rid of it. Do not choose a new component because Hacker News likes it, because seriously, fuck Hacker News. And like I said, it's totally legitimate to make software choices based on the quality and health of the community, because good communities actually make software more likely to succeed and stick around and improve if people feel welcomed and not harassed and not abused and all that shit. I feel like I'm cursing a lot for the Midwest, and this is actually really mild for me. I would like you to know I've really toned it down. I'm just like suddenly self-conscious. Lastly, all this advice really boils down to seriously considering the operational impact and life cycle of your code over time. The best engineers are the ones who do this instinctively. And I used to I get irritated when people shit talk ops. And fuck, there I do it. Operations to me, okay, so operations a few years ago, 10 years ago, back in the LampStack world, was like people SSHing into servers and doing things, right? That's not ops today. Operations today, like quality, world-class operations engineers, are the ones who are deeply skilled about thinking about the life cycle of the software and the service, about instrumentation, about debuggability, about visibility, observability, about how people can understand things in really complex systems when things go wrong, about how to, turns out building software, writing code is the easy part. Making it usable over the long term is the harder part. And that's what ops means to me today. Tangent, blah. However, because this is such a critical and challenging, legitimately one of the most challenging engineering roles out there, you should also try to make as many ops problems not your problem as possible. God bless the PagerDuties and the Pingdoms of the world. Everybody's who's making Nagios obsolete. Everybody who is, God, man, okay. I remember 10 years ago when we all ran Postfix and IMAP and our own Spam Assassin and our own antivirus. And then suddenly we all woke up and went, well, this is really stupid. We could pay Google to do this. Let's use Gmail, and we can reallocate those engineers to our core products. Yeah, let's do that for as many things as we can. Money is cheap. Engineering cycles are not. And the problems that are really core to your business that set you apart, you are going to need to deeply understand those. You're always going to need to keep them in-house. Dude, that was a rant. Anyway, culture can do a lot of heavy lifting for you here when it comes to driving the sort of behavior that you want, right? I mean, it's really easy to celebrate when people ship features. Woohoo! You know, post to the email, do a blog post, do a whatever, you know, everyone's like, yay, a feature. It takes actual conscious effort to recognize when people are doing work that makes things not break. This is, I keep talking about the jobs that leaders should be doing, right? But this is a job that engineering leads, and this doesn't have to come from managers, you know? I think of a leader as being someone who does something that needs something that needs to be done, right? And this needs to be done. So if you notice somebody on your team who did something that made something not break, like, call it out. And if you are someone with like leader, you know, manager or director, whatever in your title, like, figure out, invest some creativity and some of your, you know, emotional and mental cycles into figuring out how you can recognize these people, because they exist in your org and they're precious and they probably feel undervalued. The patterns that you call and celebrate in your culture are the patterns that will get repeated. So the things that you celebrate are just features. Your reliability is going to be shit. So here's your technical decision-making manifesto, right? Tech serves the mission. Reuse solutions wherever you can. Create some sort of process for adding new components, especially the ones that you know are going to require a lot of support, anything that's storage related. Choose boring technology, but like, don't be too risk averse, because then we never make progress, right? If we aren't spending those tokens somewhere. And the longer you survive, the longer that your horizon is, the more your operational impact trumps all. Like, the cost of development time is like, you can round it down to 0 when you're looking at operational impact over, you know, 5 to 10 years. But good news. Whoa. You're probably going to fail. So am I. It's cool. Most startups fail. Most projects fail. It's you know, but we mostly fail for lack of traction, lack of product market fit, not for technical reasons. Honestly, nobody startup has ever failed. I believe this is true. I would like to hear about it if it's not. Nobody startup has ever failed because they chose Ruby instead of Python. 15 years ago, though, somebody else was giving the same presentation, except they were complaining about how they now have to choose between C and C++ and Java. And now all these young upstarts with like Perl and Python and PHP and you know, if it's interpreted, it can't be as performant as compiled, and they're not real developers if they aren't, you know, using make. So, okay, fair. This is like, you know, a continuous thing. But that doesn't mean that these choices don't matter or don't have an impact, right? The places that they have an impact are how quickly you can move. Like, did you choose roughly the right tool for the job? How much technical debt are you accumulating and how quickly? How happy are the engineers on your team? Because that matters a lot, actually. Retention, people don't pay as much attention to retention, attention to retention as they do to hiring, which is a huge mistake. Like, I think people should be paying way more attention to retention of the people that they value. The happiness of the engineers on your team actually also has a direct impact on your ability to hire, because if you go in to interview someplace, you can tell if people are lukewarm or if they're kind of unhappy. Also, this is a really small community, and we talk a lot. We're kind of gossipy little fuckers. I know so much about so many companies, internal tech stacks and problems, that I have like a pretty extensive catalog of where I would or would not go work. And a lot of that has to do with the quality of decision making of the leaders around this sort of thing. So, cheer up. Enjoy it while you can, because these are literally already the good old days. Thank you.